Okay, back for 811, the last section for March 30th, the week of March 30th. Keep in mind you don't have to watch this video, or you can just watch bits and pieces of the video to get what you need to help through, again, just the in-class work. So today, when we start this Chapter 8 stuff, we are going to be talking about measures of central tendency, and we'll learn about those measures as we go through. But this chapter is all about probability and statistics, and we'll really be kind of surrounded by all of that. I am disappointed that we aren't able to do some of this stuff in class, because these are good ones to have some group things, like in this first problem, 8-1, taking a census. Currently, 2020, we are actually having a census in the United States, and it's a collection of data that describes the people living in a country. The U.S. government performs a census every 10 years. The government uses the data to learn such things as how the population is changing, where people live, what types of family exist, and what languages are spoken. For example, in the year 2000, there were 281,421,906 people surveyed for the census, and about 8 million of them, lived in New York. Today, we're going to take kind of a census of the class. I just put 5 students up there. Let's say that the first student had 2 people, and then the other one had 2, 3, 4, and 4. I guess I just meant by siblings, but maybe this one should have been for everybody. Either way, it was just an example for you to kind of get an idea of what that looks like. So we're going to skip the your task and go down to these bullet points right here. What's the difference between the largest piece and the smallest piece of data in the class, right? So the largest is 4 and the smallest is 2. What's the difference? Difference means subtraction. So 4 minus 2 is 2. This difference is called the range. So what we just calculated right there is called the range. The largest take away the smallest. This is one way to measure the spread, or kind of the variability of the data. If we don't have a very large range, that means that the data is very close together. If we have a very large range, it can mean the data is very spread out. The second bullet point says what number falls right in the middle of all the class when the data is sorted in order. Well, I actually have them all in order up above: 2, 2, 3, 4, 4, right? Which one is in the middle? And what I like to do sometimes when I'm trying to find the middle one is I just try to do a little cross off, right? Cross off. And when I'm working my way to the middle, there's only one number left. So that one in this case is 3. We call that the median. Median is the middle number once they have been sorted in order. Okay? So let's move to 8-2. Once each day, Erica tracks the depth of water in her local creek. Her first 9 measurements in inches are below. What's the median of her data? Well, let's jump right up above here, and if we take a look at the median of our data, that means that we need to have that data sorted in order, and then we need to find that middle number. Well, on my previous sheet here, I did already sort them out, and when I sorted them out, I had 9, 11, and you can check these: 11, 12, 13, 14, 15, 16, and 17. All in order, right? So if we want to find that middle number, let's cross them off. Let's cross them off until we get to that one. So I'm working my way to the middle to find that middle number. There it is, 13. So the median of her data is 13. Now she went and had her next 3 measurements are in inches. That were in inches were 9, 10, and 9. What's the new median? Well, we can put those numbers and match them up with everything that we've had above. So that means now that we have 2 new 9s with our current 9 from above, and then we had a new measurement of 10, and then we have all the same measurements that we had up above, right? 11, 11, 12, 13, 14, 15, 16, 17. What's our new median? Now what we're going to do is we're actually going to find out that something tricky happens here. Work our way to the middle. Right, so I've crossed off 3 on each side. 4, 5, oh, 2 numbers. Well, now what do I do, right? Well, when I have 2 numbers, I can't cross them both off and have no number. What I do is I actually find the middle of those 2 numbers, right? And the middle of 11 and 12 would be 11.5, right? Halfway between. So the median in this case is 11.5. What's the average? I took our numbers from up above. Well, let me read the question. Now obtain 1 cube or manipulate it from your teacher to represent each person in your family. So if you are one of these 5 people, maybe you're the 3, that means that you had like 3 cubes in your hand, okay? And then what you're going to do is create yourself in a human dot plot, right? So if we were to do a dot plot, we would have basically all of our numbers in order, kind of like this. If we were to share those cubes so that everyone had the same number of cubes, how many would each person have, right? That's called the mean or the average of the data. Well, if we were to share it, right, so picture this person has 2 cubes, this person has 2, that person has 3, person has 4, and that person has 4. These 2 people have extra, right? Those 4s have extra. They need to share. If this person with 4 gave this person 1 cube and this person gave that person 1 cube, then everybody would have 3 cubes, right? And if everybody has 3 cubes, what we call that is the mean, okay? We're going to learn how to calculate that part just a little bit later. So then for 8-4, again, I kind of used my own numbers from that I created. An outlier is a piece of data that is much larger or much smaller than the rest of the data. Imagine that a student with a family of 20 people joined your class. Wow, so along with our 2, 2, 3, 4, 4, we had somebody that had 20. What do you think would happen, right, to the mean and median and the range? Whoops, I missed that one in the first part. When we add that, right, what would change the most? Well, we don't have all of the ways necessarily to calculate everything yet. We know that the range would make a big change, right? Because it's the largest take away the smallest. So 20 minus 2 would be 18. That would be a big change, right? The middle number, if we work our way to that one, would be not a very large change, would it? Or if we remember before, the median was 3. Well, now it's 3.5. Our mean or our average would definitely change, wouldn't it? And I'm not going to calculate it, but we know it would change a lot because this 20, now that this person has 20 cubes to share, boy, everybody's would get a lot larger, wouldn't it? So we'll figure out how to do some of that later, okay? So, computing that mean, in problem 8-3, you found the mean number of cubes in the class by sharing those, right? Now we'll explore how this method translates into a mathematical strategy. How could you use the numbers and symbols to represent what happens when everyone puts all of their cubes together? Well, when we put all the cubes together in a big pile, that's when we add the numbers all up, right? We add them all up. So let's do that for, no, I think we need to do this, if I remember correctly. They want us to do it for 8-3, so we're going to do it with this one right here, okay? So 2, 2, 3, 4, 4. We are not doing it with the 20. All right, so let's do that actually. 2 plus 2 plus 3 plus 4 plus 4. 2 plus 3 is 4, right? 4 plus 3 is 7. 7 plus 4 is 11. And then 11 plus 4 is 15. So this will equal 15. How could you use numbers and symbols to represent what happens when the big pile is shared evenly among all the people? So when we have a big pile of 15 and we share it among the people, right, we always talk about that as division. Divide that amongst the 5 people. Each person gets 3. As you discovered, one way to calculate the mean is to add all the data together and then divide the number of pieces by distributing that, right? Calculate the mean for the typical family size of students in your math class. How does it compare to the problem you got in 8-3? Be sure to record your work carefully. Well, we actually kind of just did that already. Up above, we calculated it and then we recorded that, right? So what we're going to do is, how does it compare? Well, we notice that it is the same value when we shared those cubes out, or when we did the calculation of the average. All right, at this point you could stop. You don't have to do this extra problem, but I will show it. It's an additional challenge. 2 of the golf scores at the local tournament were unreadable, but the mean score was 85 and the lowest score was 75. If the readable scores are listed below, what's the possible scores for the other golfers? So there's all the scores. We have 9 total scores. I was doing a little work ahead of time here. These 2 scores we can't read, but since we know that the mean score was 85 and the lowest was 75, we already know that we have a 75 here. So it can't be less than 75, right? Couldn't be 74, can't be 72, can't be 50 or anything like that, right? So somehow we need to find that the mean score was 85. Well, what makes this an additional challenge is you're going to have to do some work backwards. First, if we recognize that the mean score is 85, and that's shared amongst 9 people, that's like thinking that the cubes part, going back to the family, that every of those 9 people, every person had 85 cubes. Well, that's a total of 765 cubes. Right, that's a total of 765 cubes in the big pile. But how many cubes do we know exist, right? Well, what we can do is add each of the numbers we do know, and we get a total of 606. Well, that means that if we're supposed to have a total of 765, but we only have 606, what we're going to be able to do is figure out, when we subtract that, we'll get 159. 159. I made a mistake. That one is not a 16, that's a 15, isn't it? That means that these 2 scores left, right? Those 2 scores, this one and this one, have to equal 159. So I don't care actually what those 2 scores are, as long as they add up to 159. Now, they cannot, however, be smaller than 75. So you can pick any 2 numbers outside of that, okay? Down below here are the answers that you can look at. There's that homework. Be sure to show your work. That's super important for you to kind of earn that credit for that. And if you have any other questions, anything else, please let me know.